Welcome back, my dear students. It is the third video of Unit 1 Gas Dynamics and Jet Propulsions. So, in this video, we are going to study Mach number, Mach cone, reference Mach number, and etc. The first topic, Mach number. In fluid mechanics, Mach number, it is denoted by M or MA, is a dimensionless quantity representing the ratio of speed of an object moving through the fluid and the local speed of the sound. That is M equal to V divided by sound velocity. Then Mach number. So it is in this diagram represent the zone of silence, Mach cone, and mu equal to sine minus inverse sine into A divided by U. A conical surface that bounds the region in a supersonic flow of the gas in which the sound waves emanating from a point of source A of the perturbations are concentrated. Okay, next topic, reference Mach number, that is M star, denoted by M star. In the analysis of high speed flows, another Mach number called M star is employed. It is defined as not dimensionalizing the fluid velocity by the critical fluid velocity or the sound velocity. That is M star is equal to C divided by A star, that is C divided by C star. That is M star square equal to C square divided by A star square is equal to C by A square into A square divided by A star square is equal to M square A square divided by A star square. It is more convenient to use M star instead of M because at high fluid velocity, M approaches infinity, and the second one is M is not proportional to the velocity alone. It should be pointed out here that M star does not mean M equal to 1. This only other type of the Mach number. We have H naught equal to A square divided by gamma minus 1 plus 1 by 2 C square is equal to 1 by 2 C square max is equal to 1 by 2 A star square into gamma plus 1 divided by gamma minus 1. Again is equal to 1 by 2 A star square into gamma plus 1 divided by gamma minus 1. Multiplying by 2. That is, the above equation is rewritten as 2A square divided by gamma minus 1 plus C square is equal to gamma plus 1 divided by gamma minus 1 A star square. Divided by A star square. Therefore, the above equation can be written as M star square into 1 plus 2 divided by gamma minus 1 divided by M square is equal to gamma plus 1 divided by gamma minus 1. Then M star square into 2 divided by gamma minus 1 into gamma minus 1 divided by 2 plus 1 by 2 M square is equal to gamma plus 1 divided by gamma minus 1. Then M star square equal to 1 by 2 gamma plus 1 M square divided by 1 plus 1 by 2 gamma minus 1 into M square. When M is equal to 0 at M star is equal to 0 at M equal to 0, then M star is equal to 1 at M equal to 1. Equation we have M star square plus 2 divided by gamma minus 1 M star square divided by M square is equal to gamma plus 1 divided by gamma minus 1. It gives 2 divided by gamma minus 1 M star square divided by M square is equal to gamma plus 1 divided by gamma minus 1 minus M star square. M star square divided by M square is equal to gamma plus 1 divided by 2 minus gamma minus 1 divided by 2 M star square. Then C square divided by A star square plus 2 divided by gamma minus 1 A square divided by A star square is equal to gamma plus 1 divided by gamma minus 1. Then the equation is M star square is equal to M star square plus 2 divided by gamma minus 1 M star square divided by M square is equal to gamma plus 1 divided by gamma minus 1. Then M square is equal to 2 divided by gamma plus 1 M star square divided by whole divided by 1 minus gamma plus 1 divided by gamma minus 1 into M star square. Then 1 minus gamma plus 1 divided by gamma minus 1 gamma plus 1 divided by gamma minus 1 in M star square is equal to 0. Therefore, maximum Mach number into maximum velocity divided by c star square. C star is equal to root of gamma plus 1 divided by gamma minus 1 is equal to 2.45 for gamma equal to 1.4. Therefore, CR is equal to C divided by C max at m equal to infinity. 1 minus gamma plus 1 divided by gamma minus 1, m star square is equal to 0. Then m star max is into C max divided by C star is equal to root of gamma plus 1 divided by gamma minus 1 is equal to 2.45 for gamma is equal to 1.4. Crook number, a non-dimensional fluid velocity that can be defined by using the maximum fluid velocity. C, it is denoted by CR is equal to flow velocity divided by maximum fluid velocity. Therefore, CR is equal to C divided by C max. Isothermal flow, adiabatic and reversible. No energy added, no energy losses, small and gradual change in flow variables. The earliest reference to is other molecule flow was found in Sharpe book. The model suggests that the choking occurs at 1 divided by root k, and it appears that Sharpe was the first one to realize this difference compared to other models. In reality, the flow is choked somewhere between 1 divided by root k to 1 for cases that are between fan-out flow and isothermal flow. This fact was evident in industrial applications where the expectation of the choking is at Mach 1, but it can be explained by choking at lower Mach number. No experimental evidence known by the undersigned was ever produced to verify this finding. Next topic, law of conservation of momentum. It is otherwise called as Newton's second law. Law of conservation of momentum to a system. Summation of fxx equal to d divided by dt momentum integral of system is equal to d by dt m into vxx into system for the system. So therefore, summation of x force is equal to f1 xx plus f2 xx plus f3 xx plus f4 xx. F1 xx is equal to f1 pa, f2 xx equal to minus f2 is equal to minus p plus dp a plus da is equal to minus of pa plus bta plus adp neglecting hot. F3 xx equal to f3 cos 90 minus alpha is equal to f3 sin alpha is equal to average pressure into curved wall area in sin alpha is equal to P plus dP divided by 2 AW sin alpha. But AW sin alpha is the projection of the curved wall area onto a plane perpendicular to flow direction and equal to dA. F3xx equal to P plus dP divided by 2 dA is equal to B into dA neglecting hot. F4xx equal to minus F4 cos 90 minus theta. Then is equal to minus f4 sin theta is equal to minus fg sin theta. Then d by dt m vxx for the system is the total change of the momentum and represent change of the momentum with regard to time and the change of the momentum with respect to position. The system and the CV are interrelated through Reynolds transport theorem. Therefore, d by dt mvxx for the system is equal to rho by rho t mvxx for the CV plus mvxx out minus mvxx in. Therefore, summation of xx is equal to rho by rho t mvxx for CV plus mvxx for out minus mvxx for in. Assumption. What are the assumptions for the in this flow? One-dimensional flow, steady flow, higher order terms are neglected. The fluid is inviscid, that is Mach number is equal to 0. Compressible fluid. Therefore, summation of xx. This represents the summation of all forces acting on certain volume, critical volume. CV and includes surface and body forces. Surface forces are of normal and tangential forms. Since the fluid is inviscid, shear force is equal to 0. Figure above show a flow through CV. All fluid properties at inlet and exit are represented. Various forces acting are also represented in their respective direction at the appropriate location. F4x equal to minus of a plus dA divided by 2 dx plus rho plus dP divided by 2 g into ds. Then F4x is equal to minus rho ag dz, neglecting higher order terms. Then summation of fxx equal to ba minus pa plus minus b into dA minus a into dp plus p dA minus rho g a dz. Summation of fxx equal to minus a dp minus rho g a g dz. Right hand side of 1 is equal to rho divided by rho t mvxx cv plus mvxx out minus mvxx in. Since steady flow, rho divided by rho t mvxx cv is equal to 0, mvxx out minus mvxx in is equal to m dot vxx out minus vxx in. Therefore, is equal to rho a v plus dv minus v. Then rho a v dv. Therefore, right hand side is equal to rho a v dv, equating left hand side and right hand side of the 1. Minus a dp minus rho a g dz is equal to rho a v dv. A dp plus rho a v dv plus rho a g dz is equal to 0. dp plus rho plus v into dv plus g dz is equal to 0. Momentum equation minus Euler equation. So it is a first problem. Atmospheric air at 1.1 into 10 power 5 Newton per meter square and 65 degrees Celsius is accelerated isentropically to a Mach number of 1. Find final temperature, pressure and flow velocity. Assume the given state is stagnation state. From data book is entropic table, that is K equal to 1.4 or gamma equal to 1.4. Therefore, T equal to T star is equal to 8.834 T naught is equal to, therefore T equal to 281.9 Kelvin. The answer is 281.9 Kelvin. So it is a final temperature. Then find out the final pressure. We know that P divided by P naught at Mach number is equal to 1 is 0.528 from the data book. Therefore, P equal to P naught, P star is equal to P naught into 0.528. Therefore, the final pressure is 0.581 into 10 power 5 Newton per meter square. Then, at the stagnation properties, P naught, T naught from the isentropic table, K equal to 1.4, T1 divided by T naught at m dot m1 equal to 0.708 is equal to 0.908. Therefore, T naught equal to T1 divided by 0.908 is equal to 341.41 Kelvin. Final pressure P star equal to 0.581 10 power 5 Newton per. It is already known. Then therefore stagnation temperature it is also known. We know that m equal to v by c. Final Mach number is equal to 1. Therefore, 1 equal to final velocity divided by final sound velocity. It is V star divided by C star. We know that V star is equal to C star is equal to root of gamma t or kRt. Therefore, 20.05 root of 281.9 final velocity. Therefore, V star equal to 336.6 meter per second or meter second minus 1. It is a question number 2. The pressure, temperature, velocity of air at a point in a flow field are 1.2 10 power 5 Newton per meter square, 37 degrees Celsius and 250 meter per second respectively. Find the stagnation pressure, stagnation temperature corresponding to given condition. We know that Mach number V1 divided by C1 or C1 divided by A1. Then from the table, P1 divided by P0 at M1 equal to 0.708 is equal to 0.714. Therefore, P0 equal to P1 divided by 0.714 is therefore P0 equal to 1.681 into 10 power 5 Newton per meter square. Therefore, stagnation pressure answer is 1.681 10 power 5 Newton per meter square. Third problem. Determine the velocity of sound in air at 38 degrees Celsius. We know that velocity of sound C equal to root of gamma t or k at t. K equal to 1.4. So therefore C equal to 353.5 meter per second, where R equal to characteristic gas constant. For air, 287 joule per kg Kelvin. Therefore, find out the velocity of sound at 30 degrees Celsius is 353.5 meter per second. Get temperature 311 Kelvin. So in that slide, third video, it is enough. The next video we are going to study the remaining problems. Thank you.